Okay, we're good.
All right, so you guys can see my screen, property-based testing in Python.
Yes, we
Yep.
can.
All right, that is great. Right. So yeah, thanks guys for coming to my presentation. I'd like to talk a little bit about property-based testing. For all you guys who have, I'm testing this on Ubuntu right now. Um, but for all you guys who want to follow along, I have some code demos, and you can also clone this open source repository at this SSH URL. And then I wrapped everything in Docker. So you should just be able to run something like make check and make Docker run bash in order to um, just warm up Docker cache and then get everything set up. With that, I'd like to just introduce myself. I've been working professionally for about 4 years now at 3 different companies, all based out of the DC metro area. And I think for that entire time, the one constant in my professional life has been Python. So Python for web development, Python for data engineering, Python for analytics, you name it, kind of stuff. So with that, let's dive right in. So writing tests today kind of sucks. They're expensive to write. They're expensive to maintain. Um, they're somewhat opaque to anybody who isn't intimately familiar with the test harness. You can't always be sure that you're writing the right test for your particular situation. And worst of all, it's sometimes difficult in order to convince a non-technical stakeholder in your project that testing actually does anything underneath the hood except maybe inflate your CapEx and your OpEx. Every software development horror story that I've heard or experienced has something to do with the test suite. And that's not just because that software fails in more ways than anybody without job security can care to admit, but it fails in novel and unpredictable manners. This one time I was talking to a company and they were saying how a configuration management issue in Google Kubernetes engine with IPv4 allocation pools caused, I think, a downtime in their production cluster, which is really bad for a company. Um, but honestly, like all this probably isn't news to you if you've been working in industry for some period of time. And it's easy to fall into this trap that like we're kind of powerless and believing that any endemic lack of alignment in this area is kind of eternal. So I like to say that there are two really great aspects about professional software that we can apply to software testing. The first is that we're usually using paradigms that are decades old. Professional software is usually incremental in action and incrementalist in thinking. Like we don't really like big changes. And so this often implies that there are new concepts in academia or research that we can bring to the table in our professional careers. I was talking to one professor back in college, and he was talking about how the A-star pathfinding algorithm was first implemented in research 20 years before video game industry picked it up. And that algorithm is why like the NPCs in video games don't collide with in-world walls anymore. The second great thing about professional software is that test suites usually fall under the full control of engineering. So there might be like a QA department in engineering, or there might be, say, like other parts of the code base that other departments care about. But I have yet to see something like a sales and marketing department care really deeply about how you structure a test harness versus, say, like the layout of a landing page, which really matters to them. So while serving the company is the goal of any business-oriented engineering department, it does mean that we have a lot of agency and control in how we approach testing, rather than say something like product implementation or DevOps. So our goal as professional software engineers is to write as many good tests as possible within some limited amount of time. So that was that slide. So the most important thing about writing good tests, in my personal experience, is to write good source code and to develop good habits. So this might involve things like separating out concerns in a code base by using functions instead of classes. If you're using Python, adding in type checking to your code base using something like MyPy or PowerCheck, and paying attention to software properties that I'll explain a little bit later, such as immutability, which would be creating a new object with an update instead of updating in place, or item potency, or running the same action again and again creates the same result. Things like Pylint or Black for linting and auto formatting, using Docker, Docker Compose, running local infrastructure. A lot of this undergirds the higher order testing strategies like property-based testing that we might use later on. So software testing strategies that I personally used. When I first came into software engineering professionally, I began applying this principle called functional soup imperative shell. It's a concept that's championed by a guy called Gary Bernhardt from Destroy All Software. And I found that it works really well in web development or other kinds of stateless apps and clients. So basically what this is you have this soup of functional business logic within your application. And the only time where you would actually need to have state is when you need to interact with something that is imperative, such as your network or your database. And that way you'd have as much of your business logic or as much of your logic overall encompassed in unit tests, which are very cheap and easy to run and parallelize. And you'd have the cheapest possible integration tests for that amount of code. So this strategy works great for some types of applications, but I found that when I moved into something like data engineering and building out ETL tools, this kind of concept breaks down. Like it's very difficult to apply this or unit testing to something like MapReduce, for instance. And this is because in data engineering and, for example, ETL systems, they're primarily driven by effects. So you're taking a large amount of data, for instance, and then you're applying like a handful of very simple transforms, and then you're seeing some result flow into a data sink somewhere. So in this kind of environment, what I found worked for me at the time was some form of data-driven integration test. So you'd have some form of like a test fixture, and that fixture would act as a stub as you pass in copious amounts of data and generate tests based on that kind of data. So this strategy works, but ultimately, I still needed to come up with a lot of my own Oracle values. So the own values that I have to test with. And if I came up with the wrong values, then I'd be running my integration test harness with very little added value while having the expense of running additional integration test. So at least for me, this is kind of where my personal interest in property-based testing comes from. And I'd like to mention that, even with all these kinds of paradigms, they have their own individual place and they have their own individual set of trade-offs. So definitely feel free to decide for yourself when to apply or when to not apply each one. So what is property-based testing? Let's take a very, very simple method. So this method, def add one, takes in some x as an input parameter, which is of type int, and it should return another value of type int. And what it does is it adds 1 to x and then returns it. Very simple. So if we wanted to unit test this method, one thing we could do is just to say def test add 1 and just assert that applying 5 to this method generates a concrete result of 6. And that should be completely fine. Or we could apply like some set of unit tests. So I previously described PyTest mark parameterize. This is one way that you can use it. So you can have some input and some expected value, say 5, 6, 6, 7, 7, 8. Those are all test cases that you can run. And then you can have some stub methods, let's say here as test add 1, and assert that the input is equal to the expected value. So this is kind of getting more into the realm of property-based testing because you're seeing how you're asserting that some input that you haven't defined within the stub has some particular kind of result, some property that is supposed to obey. But the problem here is that you're still defining your own values, like 5, 6, 6, 7, 7, 8. And what property-based testing does is it takes this one step further. So instead of having 5, 6, 6, 7, 7, 8, you can apply something called a hypothesis strategy in Python. And what a hypothesis strategy is essentially a stream of inputs. You can have a decorator such as hypothesis.given, and then you can apply that stream as into a particular stub method, such as in here, test add one. And this is pretty much the same method that we used before, except that we're asserting a specific property this time. We're asserting that applying the input to the method add one is equal to applying adding one, I guess, to the input. And it seems a little tautological here if you don't see the property right now, which is totally cool because we can also do something like um, applying, say, a round trip identity within property-based testing. So if we define just one more method called sub1, which also takes x as an int and then returns an int, and just takes one from x and returns it. What you can do is say, because you have add one and sub one, if I apply add one and then sub one to the same input, I should be able to get the same, I should be able to get the input as the output. It should cancel each other out and it should just be an identity method. So that's what we're kind of trying to do here. We have test add sub returns value, and you're asserting that applying the input to add one, then taking the output and applying that to sub one should equal the original value. And so this is a property identity that we're testing for, hence property-based testing. So what else is like PBT? PBT is one form of testing called generative testing. So I'd say like the data-driven integration test, PyTest mark, parameterize, all forms of generative testing. What generative testing is tests that create other tests for you. And this is a very powerful concept because this is how you're able to write a lot of tests in a very short amount of time and be able to maintain them because you have more data than you have tests. You can also say that PBT is analogous to something like a fuzzing or fuzz testing. So if you're able to, say, generate a bunch of random inputs to a particular test harness in order to pipe some requests into, say, like a particular service that you stood up or a particular application and then see how it behaves. Fuzz testing is how you do that. And it's more analogous to if property-based testing, which is more catered towards unit testing. If you took that concept and then you put on steroids and made it an integration test paradigm. So there's some documentation online about a hypothesis. Feel free to read it over yourself. Though there's the core documentation for hypothesis for Python. And hypothesis as a concept is just an implementation of it's just implementation of a property-based testing. So hypothesis.works, I think, is the consulting agency that started by the hypothesis core devs. They're looking to port, I think, hypothesis to different kinds of different runtimes. Like right now, I think they're trying to rewrite the core of hypothesis in Rust, which might be pretty interesting. Seeing how that goes. Hypothesis itself, I think it comes from a Haskell library called Hedgehog, and that might be a little weird to hear because usually people say that it's coming from a library called QuickCheck, which is true. Haskell has developed this notion of Haskell pioneered this notion of property-based testing with a library called QuickCheck, and then some other folks in the Haskell community built out Hedgehog, which is pretty much QuickCheck, but the difference is that when you're generating these test cases, it applies shrinking automatically during runtime. And what that means is you're taking some broad spectrum of inputs, and when you get some form of an error, you're trying to reproduce that error with a smaller amount and a smaller amount of user data. So that way, when you finally return the error case, you're having as little data as necessary in order to reproduce the problem. And that makes debuggability a lot better. Hypothesis takes this concept and runs with it. The core idea behind hypothesis is strategies. So you have very simple hypothesis strategies, and those map to Python's primitive values. Say you have strategy dot integers, for instance, that spits out a stream of integers. You have hypothesis dot nothing, hypothesis dot bool, hypothesis dot text, hypothesis dot character, and you can change a whole bunch of properties about these streams as needed. For example, in hypothesis.character, you can change the minimum and maximum Unicode code points that you're generating. And so that really helps in terms of applying constraints to the set of data that you're inputting into your test case. And it takes this idea of hypothesis takes this idea of strategies, and it basically just goes on a roll with it. You can create strategies from different kinds of Python structs, like dictionaries or lists. So you can just do something like hypothesis or strategy.lists, and then parens strategy.integers. And that will create a stream of a list of integers for you. You can also do things like merge different strategies together. Like if you did st.integers pipe sd.text, this will generate a strategy called one of, and it'll stream either integers or text, completely random. You can also define strategies from different kinds of Python functions. So something like st.buildS, you can just write a function and then pass that, decorate that with buildS, and then pass that into a unit test of some sort. Or you can do something like st.data, and I believe that generates the stream within your unit test. You can infer strategy from a regular expression. I'm going to go over that a little bit later. And you can also infer a strategy from a given Python type. So this is really nice for if you have third-party support for libraries like NumPy or Django, and you're looking to integrate property-based testing with those dependencies. You're able to do that right now because I think the hypothesis core devs have implemented that support. And if you needed to, you can implement third-party support on your own as well. So what kind of tactics can we apply with these hypothesis strategies? So one that we already talked about is round trip identity checks. So if you apply some method and then you already have the inverse, or finding the inverse is not that difficult, you can apply both and then get the identity back. You can search for invariant properties. So this is something like if you had taken the set of a list of integers, taking the set again should give you the same set of integers. And that's because taking the set is an idempotent operation. Apply it once and apply it again, and you should get the same result. You can also do liveness checks. So if you have say like a list and you want to check that you implemented max correctly, taking the maximum of an empty list results in a value error. So that's really helpful. So this is all well and good, but I think for me, I personally like to learn from real world examples. So let's go over a few real world examples. One really simple example that we can start off with is something like password validation, for instance. You have a method that say like, is password valid? It's completely functional. You pass in a string, you're supposed to get a Boolean out. Passing in the same string will get the same Boolean, and you have some set of arbitrary rules that you want to look for in that string. So let's say you need to have the string be at least 8 characters long, for instance. Or it needs to have some number of digits, or you need to have some combination of both uppercase and lowercase alphabetical characters. So what might a unit test for this method look like? I would personally use something like PyTest mark parameterize in this case. I find reaching for that to be very easy. So you might have some kind of input and some kind of expected value. Passing in the empty string as a password results in the method saying it's not a valid string. Passing in, say, all caps, all special characters, numbers, and special characters only might result in an invalid password because you need to satisfy all the rules of the password validator to pass. And then if you passed in the correct password or a correct version of the password, it'll say it's true. It'll say it's the password is valid. So these are tests that you can come up with just by looking at the defined rules within the source code. But you might forget that in Python 3, strings are Unicode and they're not always UTF-8. And the notion of a character and a character length might change by language. And so once you remember that, you're left wondering what else you've kind of forgotten about. So you can always just patch this in a piecemeal approach, like if your company internationalizes and moves to a different market. But this is also a great opportunity to apply property-based testing with hypothesis. Um, we have the rules available in the source code. And if we're able to generate some amount of data that fits the rules we think are necessary, we might be able to use property-based testing in order to validate that this particular property holds for all inputs. And if it doesn't, then we know there's an error. So I fiddled around a little bit on this website called Pythex. I think it's listed in the slides. And I came up with a regular expression that passes this password validation. So if we look at this particular line, the line with the at given, starting with the R, we have a number of groups, a number of regular expression matching groups. The first one is I need to have at least one digit. The second is I need to have at least one lowercase letter. The next is I need at least one uppercase letter. And the last is I need to have at least one character from this set of special characters. So maybe not all special characters, say in string.printable, just these ones. And then the last little curly brace thing is I need to have this data be 8 characters long, at least. So we can take this regular expression and we can pass it to a hypothesis strategy called st.fromRegEx. So given this hypothesis strategy, we can pass this input to this method, test password matches validation for arbitrary inputs, and we can assert that the password is valid for all of these inputs. So that's one thing that we can do. Another example is if we had, say, like web server. If you're building a web server, you're trying to make it as stateless as possible. So really should just be a pass-through entity between the REST API and some SQL database call. So in the example that I currently implemented, the database has some number of check clauses sprinkled throughout to prevent writing invalid records. So there's an employees table. Every employee has to have a name and an age. The name must exist for one, and it has to be longer than 0 characters, which kind of makes sense. And the age, we don't want to employ children, so we need to say, hey, employee's age must be greater than the 18, greater than or equal to 18. So once we have the database definition defined, we can define our APIs. So say you're taking some URL with URL parameters. Upon success, we're going to spit out like this HTTP 200 status code and some data. And upon failure, we can spit out the HTTP 400 bad request and some error message. And what it should never do in any situation is spit out some form of stack trace or some HTML error message. That means something got wrong, something was wrong. So this is a great way in order to apply integration testing. Usually Python code bases are not as clean because Python fundamentally is an object-oriented language. So you want to test at the interface level, which would mean from the API to the database layer. I built out this example using Flask, and PyTest has a great PyTest-Flask integration that allows you to build out a app client fixture. So these are 2 methods you can run. Testing it returns OK, and then test endpoint test returns OK with parameters. You're passing in the client fixture through both of them. And then you're calling different endpoints and then asserting that both of them respond with HTTP 200, the latter with some valid set of URL parameters. So this is all well and good too. But just as the example before, this kind of doesn't work for all situations. So what happens if your name had, say, a special character in it, or if you had, say, a space? And the answer is that this would pretty much fail because it wouldn't be a valid URL. So what we need to do is we need to encode this URL and then make sure that all types of names, all types of byte streams, pretty much, can be a valid name. And then we can constrain ourselves to operating on a particular age. So the property-based approach, the property-based testing approach, might take something like for my name, I want to have all types of printable strings. And because I know that the database itself will reject all names that are of length 0 characters, I need to take at least 1 character from. I need to make sure that my stream always has a stream of characters that's one character long. For the set of integers, this isn't recommended by the Pi hypothesis core devs because it does prune away search space. But you can generate a stream of integers, and you can make sure that stream has only numbers that are greater than or equal to 18. So funny thing, I think when I was testing this locally, you can generate integers that are like 1 million, and it would be completely fine. And I realized that maybe you can cap the age of something like 150 or so if you wanted to save space, such as with like an int 8, for instance, instead of an int 16. So if you have these two types of inputs, you can pass them to hypothesis.given, and those will show up after you implemented the PyTest fixture for client. So in this test endpoint, test returns OK with arbitrary inputs. You have your Flask client, and then you have your name and your age streams from hypothesis. Hypothesis has this notion of note. Note is kind of like print, except that it's hypothesis specific. And this is important because hypothesis generates hundreds of test cases on your behalf, and it doesn't print out all of them, only prints out a subset. And if it printed out all of them, then your standard out will be very cluttered. So note is a way in order to get around this. So if we took our URL stream or URL string, we parsed both URL arguments, and then we, templated that within the final URL string. We should be able to pass that to the client and be able to get an HTTP 200 response out. This doesn't work as is because I haven't implemented the database call as part of the PyTest fixture, so I will leave that as an exercise to the reader. So the final example that I had, which I didn't really have time in order to implement completely, is a data pipeline. So a data pipeline primarily using like multiprocessing and I guess you could say some form of time series. So what this does is it generates multiple Python processes, and every single process generates some amount of data, JSON data. The parent then pulls this JSON data into the same log file, which can represent some amount of data that you need to shove into a central time series database of some sort. So I guess the question that I would ask is, what happens if you needed to build out this database? And added a little surprise within this implementation is a simulated clock skew. Assuming that this represents, say, multiple Internet of Things devices running in disparate locations, all logging or registering events back to a central location. They all have different clocks. They all have different network latencies. And so there might be some form of out of orderness towards the global record set. And so my challenge to you guys will be build out a log aggregation tool that takes a form of global ordering as log stream in from different devices, and then be able to assert this global ordering using property-based testing. And then if you're able to do that, then make a pull request. I think this should be relatively straightforward. I think it's just like a dispatch method plus some kind of a merge sort plus, let me look this up, plus, I think, yeah, dispatch method plus merge sort, I think is probably the big two main things. So these examples are really quick. I whipped these up in a few days. I really highly recommend checking out the blogs of both the Hypothesis core devs. And one blog, in addition to that, that I found really useful is this guy called Wang. He normally writes about formal methods and language theory, but he does have some blog posts about property-based testing. Um, and I found them to be really useful. Actually, they melted my brain. But if they didn't melt my brain, I would find them really useful. So one thing that I really appreciate about learning about property-based testing is that it kind of changes your mindset about programming in general. Like I've learned to be a little bit more critical in terms of thinking about types. Like I kind of get like why expressive type systems are like a really nice thing now, um, and about just general properties. Like thinking about what possibly could happen instead of just what happens on the happy path. And that's been, I think, invaluable for my I guess progression as a software engineer. So with that, I think that's all I got. That's all the slides I have.
Uh, awesome job. Did we got time for Q&A? If anyone has questions.
Yeah. Ying, could you go back to your, I think, second to last example?
Second to last example. This one?
Yes. Yeah, because there is just wondering because I know that I think the first example you had of hypothesis used a pretty, or used a regular expression. What are your thoughts on, you know, on regular expressions in testing? Because I know one of the things that I struggle with being not super experienced with regex, though I use them far more than I should, is I find them far less readable than a similar expression of business rules. So I'd love to hear you elaborate a little bit on that in terms of not just how to write better tests, but how to write more readable tests.
That's actually a really great point that I wanted to bring up. I think yeah, that's a really great point. So I think one thing that I would say is that from regex is one strategy that's implemented by Hypothesis, and I don't think it's actually one of the more popular strategies. I personally use it because I think regular expressions generate more different, like more diverse types of data. This strategy like st.text. But st.text and st.character are available for you, and they're definitely encouraged, I think, by the Hypothesis community. It's actually funny because when I was writing this presentation up, I was actually flailing around with the regular expression and I think throttling my computer because it's trying to generate so many different types of expressions that I just didn't know what to do. So yeah, I definitely get the understand the problems behind building out regular expressions in terms of generating regular random data. One thing that's definitely helped me is that site pytex.org. I think coworker on a previous place had some previous place I think had shown it to me, and I think that's been invaluable. Just being able to see the kinds of I guess regular expressions and the types of data that match those regular expressions, and just being able to learn more about regular expressions in general. For me, I'd say in addition to that, regular expressions do have like some amount of that randomness, and you do have that fine grain level of control that you might not have as like using like st.character or st.text. So that's kind of why I wanted to bring that out there to show you like the possibilities in terms of what you can generate with hypothesis. Um, but yeah, I think it's up to everyone's preference and depending on what works. The core idea I think behind hypothesis is just to prevent you from writing like too many of your own like unit tests and your own Oracle values and stuff like that. And as long as that as long as it works and as long as hypothesis is happy, I don't really think it really cares. It really matters all that much.
That makes sense. Thank you.
Um, well, first, thanks for a great talk. I've heard of Hypothesis before, but I've never really seen it beyond the toy example. So it was really useful to see these more intricate or real world kind of tests. I think one thing where I always fall off with these is we're all dealing with primitive types here, like strings, integers, etc. How do you, how well does Hypothesis kind of grow into what beasts might lurk in our business logic of accepting dicts with many like intra-field dependencies where it could really be broken off into a class or something more object oriented. But like, how do you scale this beyond just accepting primitive types and all the permutations there?
That is a great question. Because if you can't scale beyond primitive types, then like I don't think any testing framework would be appropriate for Python in general. So I can't really speak directly, I think, to being able to use like hypothesis in more complex situations. But there is this one great blog post that I found by the guy called Wang, where he takes a class called exam, and it has a number of different attributes. One of them, I think, being like typing.optional. And he manages to create a number of property-based tests based on that class. Let me see whether I can find it right now and show it to you guys. So this is hellelwayne.com. This is complex property testing with complex inputs. So let me post this in the chat. I wonder if I need to stop the screen share in order to post in the chat. So this is that post. So you can go and take a look at that. But I think in general, hypothesis not only scales well to more complex types of data, but it also works for, it integrates well, I think, with stuff like PyTest and other forms of testing libraries. And it also doesn't have to be stateless tests. So you can do things like, I think, combine property-based testing with a library like PyContracts or like contract-based testing in order to create a property-based integration test. And I think Hillel also mentioned that as his first, I think, seminal blog post. So there's a number of different ways that hypothesis can grow in order to serve your needs. And yeah, you're not really capped, or I don't find that I'm personally capped by hypothesis just yet.
Cool. One thing, I think your Zoom might be set to direct message someone because I don't think there's a message in chat.
Yeah, I did. All right, there we go.
Thank you.
Hey Ying, I had a quick question. Can you go back to that example that you had with the st.integers?
Yeah, let me share my screen. Property-based testing, share, st.integer here.
st.integers, you said, is a stream or a generator, generates whatever. And you mentioned that it recommended not to use dot filter where x is greater than or equal to 18 to get the only the numbers that are greater than 18. So then what is the recommended way if you're not supposed to filter the generated sequence?
So the idea, I think, behind like property-based test or hypothesis in general is that you're supposed to allow the shrinking as part of the generation process take care of reducing the search space. You're not supposed to, I think, manually reduce the search space yourself, because when you're doing that, then it's easy to become, I guess, beholden to like the kinds of the manually fallible errors that come up with conventional unit tests. That being said, because I had the explicit check inside the SQL database, like I knew those tests would not pass. And I just added this here because honestly, it was like a few hours before this presentation, and I couldn't be bothered to figure out the proper way. But I'm pretty sure that there's probably a better way in order to do this. And I would follow up, I think, on like Stack Overflow or I think on the IRC channel for hypothesis in order to figure out where I could improve better.
Cool, thanks.
Can you explain the shrinking a little bit more? I'm not sure I fully grasped that concept. So, you call one of these strategies and it generates every int, but there's some kind of shrinking?
Yeah, so if I had to describe this, let's say you had a constraint within your source logic that said, I return false, or I error out if like input x, which is int, is less than or equal to 0, for instance. So if you passed in a strategy called like st.integers, it will generate something like negative a billion or negative a trillion or whatever, some really large value. And then it'll get like some kind of an error. And what it will do is say, I got an error with this large value, but it might not help me to get this kind of value. Let's see whether or not I might be able to reduce this down a little bit more. So it might intelligently try something like negative 1,000, for instance. And if it errors out there, then it tries like 0. And if that errors out, then it might be like, okay, well, 0 is this kind of like very simple like identity kind of value. So I'm just going to return this as like the able to reproduce the same error case as negative 1 trillion. For like, say, this might extend to different kinds of types as well. Let's say you're doing a really horrible password validation thing where you're saying a password longer than 8 characters is going to return false. And so if you passed in sd.text, it might generate, say, like a really long string. And that might fail your password validation method. So it might try like a slightly shorter string and a slightly shorter string until it got to the point where it could not reproduce that error anymore. And then I'll return that singular value as a representation of all the different kinds of things it's tried for that particular strategy. So what this does is it helps improve. It definitely helps improve, I think, the readability of your test results, and it helps you just in terms of say being able to just run the test like really quickly. Just if you had to check in that value as an Oracle value within, say, like a manual unit test suite, it just makes things like a lot easier, I think, on you as a developer. I mean, I think in certain cases, like I think Hypothesis probably supports like seeds. So if you wanted to have like a deterministic strategy, you can do that. Or let's say like if you had, say, like a problem where you suffer some amount of like integer overflow, like some number beyond like some really great number, and it couldn't reproduce like that particular error with a smaller value, it'll still give you the super large value.
Okay, so I think a piece of nuance I missed is that a singular test here doesn't just return pass fail like PyTest. It says for this range of properties, this function passes. Oh, cool. Okay, awesome.
Like PyTest and then pass in the flag like dash dash show hypothesis stats, statistics or something like that, and it'll tell you how many tests like were invalid, how many tests passed, how many tests failed, and what kind of like stringing like it actually did underneath the hood.
Yeah, really cool. Okay, thanks.
I actually had a question, sort of related to, I guess, speed, because you mentioned it runs the tests hundreds of times. Does that basically make your tests run significantly slower because of that? Or is it still approximately the same?
That is a wonderful question, because I encountered this exact problem at PyCon 2019. So I was at the build sprints for a product called Secure Drop. And what this product did is it's basically an online dead drop for journalists in order to make sure that they don't die if they report the wrong thing to the wrong person. And it's maintained by this organization called Freedom of the Press, which is an open source advocate and uses Python for secure drop. So I was working with these guys and trying to implement property-based testing for the first time. And one of the seminal tests that I implemented was serialization and deserialization of a cryptographic algorithm. Because ideally, like if you're trying to encrypt and then decrypt something, you're able to get the same result back. And when I ran this on my local machine, I think it took maybe, I don't know, it took maybe on a scale of minutes, like at most. It probably took seconds. But then when I pushed that change up to the CI pipeline, it actually took, I think, maybe like 40 minutes more. I basically blew up the pipeline. I made the world a worse place that day. And so I actually went back to the Zach Hatfield DAWs and I'm like, yo, man, WTF, what's happening here? And he's like, so basically how cryptographic algorithms work under the hood is that they're accelerated with hardware. And if you're running a CI pipeline in a virtual machine that may not have access to that cryptographic hardware, it will result in these like massive slowdowns that you're seeing. And I'm like, oh, that actually is a thing that is, scaled up because we're running so many tests, or because Hypothesis is running so many tests. So, I mean, it's really hard for me to speak to I guess like general cases where this might be a concern, but I will say that I've experienced this myself and that it'll be really important to test this empirically in all the environments that your code is going to be running, especially in resource constrained environments like build pipelines? Great question.
Cool, guys. If there's no more questions, I will stop the recording. Awesome talk. Thanks, Ying.